If we have a quadratic function given to us in vertex form, it's going to be very easy to graph. So when our function is written in vertex form, the vertex is the pair h, k. And the only complication here is notice that we have x minus h. So whatever we have in parentheses there, we're going to need to think of as subtraction to figure out what the value of h is. But our vertex is at the point hk. If the number a is positive, the parabola opens upward. If it's negative, the parabola opens downward. So a parabola that opens upward looks like this. A parabola that opens downward looks like this. And then for any number, if we move that amount to the right of the vertex, or that amount to the left of the vertex, we get points with the same y-coordinate because of symmetry. So if we have h, and then over here to the left, at distance d, we have h minus d. Over here to the right, at distance d, we have h plus d. Same distance from h, but on either side, those are going to give us the same y-coordinate. Let's look at an example graph, and let's notice these features. To graph a parabola, remember, we need the vertex and 2 points to either side of it. With the function given in vertex form, that's going to be easy to find. As our first example, let's sketch the graph of h of x equals 2 times x plus 3 all squared plus 1. And remember, we want to think of this as in the form of a times x minus h all squared plus k. Now, to work with this x minus h versus x plus 3, we notice that x plus 3 is the same as x minus the opposite of 3. Right, subtraction is adding the opposite, so logically addition is subtracting the opposite. So our h is negative 3. And then our k is the number we're adding, is just 1. So our vertex is at negative 3, 1. And our axis of symmetry is going to be x is negative 3. Now we want to get 2 points to either side of the vertex. So I'm going to make this table and I'm going to put the vertex in the middle. So I'm going to put x is negative 3, y is 1 right here. And then for my other points, I'm going to go the same distance away in either direction. So I don't have a fraction here, so I'm just going to step 1 away. So 1 to the left, 1 to the right. So negative 3 minus 1 is negative 4. Negative 3 plus 1 is negative 2. And then for my other point, I'm going to step 2 away. So I'll subtract 2. Negative 3 minus 2 is negative 5. Negative 3 plus 2 is negative 1. And why did I do that? Because now I expect these 2 points to have the same y-coordinate, and I expect these 2 points to have the same y-coordinate. And I'm going to go ahead and fully calculate those, but that's going to give me a good check on whether I'm doing all of this right. So h of x, to take h of negative 4, we'll say 2 times negative 4 plus 3 squared plus 1. That's going to be positive 3. H of negative 2 will take 2 times negative 2 plus 3 squared plus 1. And that's also going to be positive 3, which is what we hoped would happen. In taking h of negative 5, we'll have 2 times negative 5 plus 3 squared plus 1, which is going to work out to positive 9. And down here we'll have 2 times negative 1 plus 3 squared plus 1. Also works out to positive 9. Okay, so it looks like we want a y-axis that goes up to 10, and an x-axis that's mostly interested in negative numbers. So using these points, our vertex is at negative 3, 1. And then we have a point at negative 4, 3, and another one at negative 2, 3. And then we have a point at negative 5, 9, and another one at negative 1, 9. So then when we fill in our parabola, starting at the vertex, making a smooth curve up through our points to the right, a smooth curve up through our points to the left, and here we have it. This is our graph. And notice that this graph doesn't have any x-intercepts, right? The whole thing lives up above the x-axis. And it has a y-intercept, but its y-intercept is way off screen. So if we tried to graph this using the intercepts, we'd be kind of out of luck. So this method where we use the vertex form, we find the vertex and we take points to either side of it, is going to work for a wider variety of parabolas.